Okay, everybody, let's take a look at these piecewise functions. Emphasis on the fun. All right, everybody, so let's take a look at what these are. You'll see up here at the top, I have this function and it's broken up into pieces, hence the name piecewise function, because it's literally a function that I follow different pieces at different values of x. So let me explain how this is working. The function f, this rule applies. I would follow 2x plus 4 as long as x is less than or equal to -2. If I'm looking at a value where x is greater than -2, I would follow this piece of the function. Okay, good. It's kind of like, so a practical example, you might see something like parking at the airport. For the first 24 hours, maybe you pay, I don't know, say it's $5 an hour. But then anything past 24 hours, now they might charge you by the day. So you'd be following different functions depending on how long you're there. Same idea, okay? So let's try this. If I wanted to evaluate the function when f is negative, or I'm sorry, when x is -4, what I'm gonna do, remember, it can't exist at both of these at the same time. So I'm either gonna be on this path or I'm gonna be on this path. So what I do, if x is -4, I come over here and I see where does that fit in? Is -4 less than or equal to -2? Or is -4 greater than -2? Which one? The top one, right? Is it -4 less than or equal to -2? Right? You with me? Okay, so I look over here. This is sort of my, I don't know what you would call these, my restrictions. So I got to look over here and see which piece it applies to. I can't tell you how many times kids will do this problem and they'll give me 2 answers. First of all, then you have no idea what the function even is, because when you plug in one x value, only one y value should come back out. You're not going to plug -4 into both of these. It doesn't exist at both of them. You look here, figure out which one -4 fits into, and then you're like, oh, it's the top one. So then I'm going to go ahead and plug in -4 into the top. So I'll be doing 2 times -4 plus 4. So my final answer in this case is, what's that, -4 in the end? Right, -8 plus 4. Okay, so now I move on to -2. Again, it's only going to work in one of these. By the way, sometimes you have a piecewise function that's broken up into more than 2. You could have it broken up into as many pieces as you want, but each x value will only work in one of the pieces. It should never work in more than one of the pieces. If it does, it's not a, well, could it be a function then? No, someone messed up. Either I messed up or it's a typo. But anyway, -2 itself. Does that work in the top or the bottom? The top. -2 is less than or equal to -2. So I'm going to plug in -2 right here. 2 times -2 plus 4. And then I just evaluate like I normally would. That ends up being 0. Now I ask you f of 0. So again, you start all the way on the right. Where does 0 fit in? Top or bottom? The bottom this time, right? So then I plug in 0 into the x squared minus 4 piece. You with me? So that would get me 0 squared minus 4, which is just going to end up being -4. Oh, geez, these pencils. Oh my gosh. And the last one of these, 3. Does that work in the top or the bottom? The top. So plug it into the top and get your answer. I meant to say bottom. top came out of my mouth, but I was thinking the bottom one. Thank you. Okay. So far, so good. All right. Now let's see what this thing looks like. Okay. So here is what I would advise you to do, especially if you are new to piecewise functions and you don't really know what's going on here. I would advise you, if you have a different color, like a highlighter even, or I guess I'll use a, you don't have to, but it's helpful. Well, I think I'll use. All right. This graph, right? So if we're going to graph this function down below, see how at -2 is where things are changing, right? So -2 is where I'm switching from one graph to the other, one piece to the other. That's like my breaking point. I'm going to follow this function when x is less than or equal to -2, and this one when x is greater than -2. So -2 is an important value here. You with me? So what I like to do is where x is equal to -2, I'm just going to set myself up. I'm just going to draw myself. Gonna maybe highlight that region right there, just so I know, hey, the graph is going to change. Let me put something darker. Let's try this. This one's thicker. Does that show better? No. I'll try orange. This is not part of the graph. It's just helping me visualize. Okay, the top thing is only going to exist over here, and the bottom thing is only going to exist over here. Okay, you with me? All right, now you got to graph it. So here you have some options. I don't really care what you do, but how would you normally graph 2x plus 4? Y equals 2x plus 4. Where do you start? You start at 4 on the y-axis, and then you go up 2/1, right? So what I could do is I could sort of just sketch out where that line would be. But remember, it only exists over here. So I'm not going to draw it over here, but I could line up my lines if I wanted. And then only draw it from here back. That's one option. The question now comes to, okay, at -2, I do have this, I'm still on this function, right? When x literally equals -2, I'm still here. So I would put, when it hits that dotted line, I'd put a big old solid dot right there. Another option, if you don't like that, okay, if you don't like only graphing the line on the piece that it exists, what you could do is you could come back to -2, plug in -2 and see what you get out. So if you plug in -2, you get out 0. So you have that. And now you know, okay, the slope of this line is 2. So couldn't I just go, instead of going up 2/2, I could go down 2 back 1. Oops. Let me straighten out this line a little bit. There we go. So that's another option. If you wanted to plug in that value and see where your graph starts and then just follow the slope. That still is a slope of +2, right? Because as I go from left to right, I'm going up 2/1. And now I'm going to graph x² - 4 in this whole region where x is greater than -2. First of all, do you remember what x² - 4 looks like? Cedric? It is a parabola. Do you guys remember where its vertex would be? Jake? Yeah, it's at 0, -4. So this thing has a vertex right here. Where's that coming from? If you forgot, you could do -b over 2a. And since b is 0, you kind of get that 0 is going to be the x coordinate of your vertex. And then you just plug 0 back in and you get 0, -4. And then, do you remember how to graph quadratics when a was 1? Yep. You're close. It's up 1 over 1, and then it's up 3 over 1. It's the odds. Yeah, it's up 1, up 3, up 5, and then so on. Okay, so there is my fancy parabola, which makes sense because this thing should be crossing the x-axis at +2 and -2, and it is. So I'm just going to connect the dots to make this parabola. Now, it just so happens that they happen to meet right there at the dotted line. Yep.
You go over one, you're going up the same amount. It's like how you said you go up 1, then you go up 3, then you go up 5. It's like you go over 1, so then you go up 1, or you go up 4. It's so different from 3.
Oh, you mean from the original.
Right.
So up 1, up 4, and then you'd be up what? What's the next one?
It's 4, so it's 1, then 4, then 9.
Oh. Oh, I never did it that way. I always did just from one point to the next. I did 1, 3, 5. But yeah, I mean, that works too. So however you learned it, stick with it. But there we have it. Now, I know what your question is. You're probably thinking, okay, but Mrs. Sabia, this graph doesn't actually, this bottom, the parabola, it doesn't exist at -2. Correct. So if these two hadn't met at the exact same point, we would have put an open circle at that dotted line. But since my open circle and my closed circle are overlapping, it just stays closed. So there you have it. You just graphed the piecewise function. Look at you go. Let's try the next one, shall we? Oh, 3 pieces now. Holy Toledo. That's all right. So this graph is going to be y equals -x only when x is less than or equal to -2. It's going to be y equals -3. So just a perfectly flat line at -3 in between the x values of -2 and +2. And then we're going to go up to 2x plus 1 for any x values that are greater than or equal to +2. Okay. See, we had a little mistake, so we fixed it. Yours says a plus there too, right? Yeah, it says +2. Perfect. Okay. All right. So let's try. You try finding the 3. Find f of -2, f of 0, and f of 2. Let me give you a minute. Let's see if you end up with the right spot. So always look over here to figure out what branch you're going to use. What piece do you get to plug into? Okay, you got some values? Let's see. F of -2. Where does -2 itself, which branch am I going to plug it into? The top, the middle, or the bottom? Raylan? The top. That's the only spot where -2 fits. So I'm just going to do -2. So it looks like I'm going to get out a +2 as that answer. Agreed? Okay, where does 0 work? Top, middle, or bottom? Anna? The middle. So that just means it's just giving me my answer. It's just, hey, your answer is just -3. You don't even have to do anything. And where does 2 work? Positive 2. The top, the middle, or the bottom? Jake? The bottom. So I'm going to do 2 times 2 plus 1. I get 5. All right, awesome. So now down below, I have 2 values where things are changing in my graph, right? 2 values. I have a change happening at -2, and I have another change happening at +2. So I'm going to put my dotted lines at both of those just to help me sort of section off my graph. So I've got something going on at -2. So let's just to help me out, visualize this. And then at +2, I have something else going on. Okay, so I'm only going to graph the top in that section, the middle, right in the middle section, obviously, and then the bottom over here. Does that make sense? So for -x, right? Normally we start these graphs at the origin. So it's not a terrible idea to get yourself set up. But then when you go to actually draw the line, you only draw it all the way over here. If you prefer, I don't care, this is up to you. You can also plug in -2, which we already did, right? If you plug in -2, 2 spits out. That means when x is -2, the y value that's coming out is +2. So that is part of my graph right there. And then if I just want to follow this, it's just a line that has a -1 slope. So wouldn't it just look like this? Are you with me? Isn't that the line y equals -x? But I'm just drawing it all the way over on this side. I don't draw it all the way through. If you prefer, you can, okay, if I was going to graph this and I didn't have any of these pieces, y equals -x, I'd start at the origin and I'd go down 1 over 1. So when you're lining up your ruler or whatever you're going to use, right, instead of drawing the line all here, you only draw it here because this is the only piece where it exists. You with me? Yeah. I plugged in -2 because I know something's happening there. So I took -2 and I plugged it into the, well, you did it right here, right? When you plug in -2, you got out 2. So -2, 2 is a point on my graph.
Oh.
And now, since I know that's part of the top graph, right? So this point has to be on a line that has a slope of -1. So that's why I just sort of backtracked.
Answer.
Yes.
Okay. So then.
Well, that's not a slope though. That's just the line y equals -3. So it's just going to be perfectly flat. If it was -3x, then it would just be a line that had a slope of -3.
That's just a flat line.
In this one, yep. So for this, in this case, everybody, in between the values of -2 and +2, we are just going to have this flat line, y equals -3, right? If I just gave you a graph and I said, hey, graph y equals -3, don't you just do a flat line at -3? Yeah, so I'm doing the same thing. I'm only going to draw it though in this middle section. So at -3, I'm going to draw a horizontal line. Now, I ask you this question. I'm going to make it kind of thick so we can tell that there's a line there. Does this graph, oops, sorry, does it exist when x is equal to -2? No, look up here. It's only when x is greater than -2 or less than +2. So it doesn't actually exist at -2. So how do I show that? I put a big old open circle where this thing hits -2. That's how I show, hey, it doesn't exist here, but everything after that. Same thing on the other side. It doesn't actually exist at +2. So I put a big old open circle. Does that make sense? We're all right? Okay, and now I just have to graph the bottom one. So again, you could graph the line 2x plus 1 like you normally would. You would normally start at 1 and then go up 2 over 1. But you're very quickly going to say, oh yeah, we're going to get way off the graph on this one. I don't know what Mrs. Carboni made all of these. She went way off, but that's okay. It's fine. So any Hoosers. So yeah, you could set up your graph. You would normally start at 1, go up 2 over 1, up 2 over 1. So I know I'm going to hit right here, and then I'm going to keep going up 2 over 1, up 2 over 1. So I would only draw it in this section. Alternatively, you could take the value of 2, plug it into 2x plus 1, what comes out 5. So I know I'm starting at 2 comma 5, and then just follow the slope up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1. So this one does go a little bit up off the graph. Whoopsie doodles. But you know what? Sometimes things don't work out the way you expected. Yes. Go so fast. Oh my gosh. Make sure you put your phone in the box. Thank you. Let me ask you this question, ladies and gentlemen. What's the domain of this thing? What'd you say? It is all reals. The domain is all reals. Even though you have some open holes here, it doesn't matter because there is a closed hole somewhere else. Or I shouldn't say hole, a closed dot elsewhere. So if I am doing my American Ninja Warrior challenge and I'm trying to get from the left to the right, it doesn't matter if I have to move up and down. I just need to be able to get all the way from one side to the other. Yes, I reach a hole, but there's somewhere for me to go if I just go up. And then I can keep going. I can get all the way from the left to the right without having to jump. Yes, I have to move up and down, but that doesn't matter. I just need to be able to go all the way to the side, and I could. How are we feeling? Goodish? Yes. Sure. Keep an eye on Jupiter for what I end up assigning. Okay, everybody, the next one here. Now things are a little bit different. So let's take a look at what's happening here. Now, I have to come up with the piecewise function. It's not given to me. Okay, you with me here? All right. So let's see. I like to start with three. So clearly I'm going to have 3 pieces, right? I have 3 parts to this graph. I'm going to start by figuring out what those restrictions are. Okay. So it looks like I have this first piece all the way on the left is only happening when x is between -3 and 0. Do you see that? So this piece of the graph will only happen when x is greater than or equal to -3, but at the same time less than or equal to 0. So, oops, I'm sorry. If I'm in that region, I'll be following this leftmost graph. You follow me? So what would my sort of breakdown be for this middle piece? Where is that existing between what and what? Jake?
So x has to be greater than 0, but it has to be less than or equal.
Yes. Do you guys see that? Notice how it has an open dot at 0. So I'm not going to have the or equal to part. It has to be greater than 0, but I still want to be less than, but now I could be or equal to 1. Okay, and now try the last piece. So this you can assume just keeps going on forever. What's the last chunk going to be? Jake, tell me.
X has to be greater than 1.
You got it. X has to be greater than 1. One thing you might want to do before you go on is just make sure that there's no overlap here. So if you say to yourself, okay, if I plug in 0, it better only work in one of these 3. So if you had accidentally put the or equal to thing down here, you would say, oh shoot, if I plug in 0, is it this one or this one? That's a sign to you that you mess up. So, okay, 0, yep, it only works in the top. I don't know, +1 only works in the middle, right? +2 only works on the bottom. So if you just try a couple values and make sure that there's no overlap in your restrictions here. Now it's up to you to figure out what the equation of these lines is. I think you can. Let's do the first one together. I know it's y-intercept. That's always easy, convenient to know, right? So if I'm going to do y equals mx plus b, I just got to figure out the slope of this thing. What's the slope? Cedric? +1/3, right? Isn't that thing going up 1/3? And it's just hitting my y-axis at 0. So the equation of this thing is just going to be 1/3 x plus 0, but I don't need the plus 0. That's the equation of that thingy right there. You try the middle one. Anybody think they have it? Henry, you? -4x.
Oh, +2.
Yes, perfect. -4x plus 2. Did everybody see that? So we have a slope of -4. I'm going down 4/1, and my y-intercept is at a +2. Okay, so that's that chunk. Now, how are you supposed to do the third chunk because you don't know what the y-intercept is? I mean, kind of, don't you? Just extend the line and you can see where it hits. So sometimes if you're lucky enough, you can just say, okay, well, the slope is clearly -1. So if I just going back one more, wouldn't that thing have crossed at 3? Right? You see that? So, I mean, that's the easiest way. If you can't do that, I mean, you can always take 2 points on this line and write the equation. That's annoying, but you could do it. Oh, I guess not that bad. You can tell what the slope is pretty easily. So if you just have a point in the slope, you could do it in point slope form. It's not that bad. But this one, it's relatively easy. I can clearly see it would have crossed at 3 had I just extended that. So who's got the third branch? Cedric, go ahead. You got it. -x plus 3. Does all of that make sense? It does? Well, Piecewise is going swimmingly then. Why don't you try the second one if you haven't already? You try the whole thing by yourself. I won't even walk you through it. Make sure as you're setting up those restrictions that there's no overlap, because you can't have that. You can't be able to plug in, I don't know, 2 or 3 or whatever and have it go work in more than one piece. Okay, you've got something? Let's start with the restrictions. Where's the restriction for this leftmost piece? Where is this happening? Jake, tell me.
X Has to be less than or equal to -2.
Correct. Less than or equal to, because this has a closed dot at -2. That's how I know it's the or equal to. The middle piece. Cedric, go ahead.
X is greater than negative. X is greater than the -2, but is less than or equal to.
You got it. So there is that middle chunk, making sure that you do not have the or equal to with that -2. Because then I'd have an overlap. And then if I try to plug in -2, where am I going? The top, the bottom? It only should work in the top. So make sure you don't have the bar right there. And again, you know that because it's an open circle there for the middle chunk. And then that third piece has to exist where X is everybody. Thank you, everybody. Oh, you guys. Anyway, there it is. Okay, so there are my sort of breaking points there. And now I just need the equation of each thing. This is just a flat line of 3. So what do I write? Just 3, right? Because that's just the line y equals 3. This thing looks like it's crossing at +1. So I know it's going to be a something plus 1. And then what's the slope of this thing? I agree, -2/3, right? Because we have a good point right there to get to the next one, down 2/3. So that would be a -2/3 x and then just a +1. Now this one, you can either just take a ruler or something and see if you can see. It looks like it would hit right here at, oh, what's my, hold on, what's my slope? The +2. So if I go down 2/1, down 2/1, down 2/1, I would have been at -3. Right? So put it all together. What is it? 2x - 3. I agree. Does that make sense? How do we feel? Everybody's okay? Make it a little bit darker. I'm sorry about the lighting in here today. Okay. So we're feeling confident? All right, good. Okay, if you want to try the back, you can. I'm gonna let you guys get started on your homework though.